in order for us to make that decision, we need that bell shape if we're just looking at a graph. So clearly the first one and the last one are not that bell shape. So even though the first one is symmetrical, you can see that the probabilities at the ends actually are quite large in comparison to the data. It's not tapering out like we would be familiar with for the normal distribution. We don't have that bell shape. So here, the answer would be definitely no. So it's these ends here that aren't tapering out. The middle one, well, it is kind of bell shape. You've got that peak at the centre, so possibly the normal distribution could be a good fit to model that particular set of data. Here, definitely not. So it does kind of start up, but then you haven't got that kind of bell shape coming back down. So again, definitely not for that one. What about the next lot? Yeah, good question. How symmetrical is symmetrical? It's got to be fairly symmetrical, but given that you've got a minimal amount of data, it doesn't have to be perfect. Because remember, we're just trying to model it. We don't have, nothing's going to fit necessarily perfectly. So with D, yeah, D possibly. Hard to tell. So I would say more likely, yes. I can't give a definitive yes, but we do have, that peak at the centre. We've got some kind of symmetry there. We'd need a bit more data to make a formal decision. Whereas clearly this one, no, you've got this peak coming out at that bottom end. So that is not ideal. And similarly with this one. This one here actually would be more uniform. So you could possibly use a uniform distribution to model the data, but certainly not the normal distribution. So in the questions to follow, we're looking for those key features. So this was just a quick visual. In the next lot of questions, we've got some information about the data, some means and standard deviations, and based on the information, we make a decision as to whether the data could be used, the normal distribution could be used to model that particular data. And a standard deviation of 0.8, what would we expect those to be if it was normally distributed? What would we expect here and here? So your standard deviation using your 0.44 and your standard deviation. How could we do that quite quickly? If my calculator decides to load. What could we do? Of course. So inverse normal distribution, Sentinel setting, whoops. So central probability is 0.5, standard deviation is 0.8, and the mean is 4.44. Whoops, what's happened here? So we would expect the lower quartile to be 3.9 and the upper quartile to be 4.97, so say 5. We would expect the lower quartile to be 3.9 and this one to be 5.0. Are we getting that? Right, we're not getting that, are we? What do we have? We have the lower quartile is 3.72. So we're out by 0.08. Now that 0.18 might not be much. It depends on the numbers. So it's best to probably check that out as a percentage. So if we're out by 0.18 out of the standard deviation, we're looking at about 22.5%. We're off. That's quite a large percentage. We have a upper quartile of 5.12. And we would expect according to my calculations, did I do something wrong here? So 5, so 0.12. So a bit less, but still a reasonable percentage there. What else can we say about this? Correct. Yeah, the median, which is 4.4, does not equal the mean of 4.44. So you have the median not equal to the mean, although it's not too far out. You've got, well, I don't know, what's 0.04 out of 4? That's still a reasonable difference, I guess. When the numbers are low, the lower the numbers, the more obvious the difference or the error. But you've also got your quartiles out. So I could be a bit more accurate here and say, well, 0.12 divided by 0.8. I don't know what that thing is. So we're looking at a 15%. We're out by 15% here. So we're a bit too far out. Like if you're only out by 1% or a couple of percent, then that's okay. A bit too far out. So I would suggest normal distribution is not the best fit here. You know, a couple of percent is okay, but when you're looking in excess of 20%, then that's starting to get too high. All right, have a go at the next one. So this is what we would expect. We would expect 3.05 as the lower quartile, 6.95 as the upper quartile, and we have here 3.1 and 7. So you can see here that difference in terms of the number of standard deviations away is 1.73%. And the other one, which is 0.05,
is
so
there sort of like a range of percentage?
just a couple of percent, within a couple, maybe 5%, within 5, yeah. So you've got some small differences there. This time we don't have the median. So I would say, yes, this one, not much difference. Now I'm comparing that to the standard deviation. We could compare it to the actual value as well. So 0.05 and the actual value, well, that's a difference. The actual value was 3.1. And work that out as a percentage. So there shouldn't be too much differentiation, basically. Within a few percent is really what we're looking for here. So yeah, here basically we want these two to be around about the same. It doesn't have to be perfect, but close to each other. So 34% one side, 34% the other side is what we're looking for. Regardless of the percentage here, regardless of the percentage, those two are not close enough. There's quite a big difference between them, given especially there's only 409 data pieces. Maybe if we have 40,000 data pieces, then the difference is not going to be much in comparison. But here we've only got 409 data pieces. We do not have that symmetry across the two. And so therefore, regardless of anything else, we can say that the normal distribution is not a good model.